vector spaces. So the question is, find all the vectors in R3, that is 3 dimension, of norm 1, that is of length 1 unit, that are orthogonal to the vectors u equal to 1 1 1 and v equal to 1 1 0. So let w is equal to w1 w2 w3 be a vector that is orthogonal to u and v. So we will have to find w. So we can write that w comma u and v dot w is 0, that is the dot product of uw and vw will be 0 because they are orthogonal. Now we will write that 1 1 1 dot w1 w2 w3 is 0. So from the first thing we can get an equation as w1 plus w2 plus w3 equal to 0. Now on the other side we can write 1 1 0 dot w1 w2 w3 equal to 0, that is the dot product of 2 is 0. Thus we get an equation w1 plus w2 equal to 0. Now on solving these two equations 1 and 2, we get w3 is equal to 0 and w1 is equal to minus w2. Now since the norm is 1, we can write mod of w1 equal to 0, or norm is 1. So w1 square plus w2 square plus w3 square, root of it must be 1. So also the sum of squares will be 1. Now we know that w3 is 0 and w1 is equal to minus of w2 from the equations 1 and 2. So we can write w3 is equal to 0 and w1 square plus w2 square is equal to 1. w1 is equal to minus of w2, and hence we can write w1 square plus minus of w1 whole square equal to 1. So 2 times w1 square is equal to 1, hence w1 will be equal to plus minus 1 upon root 2. So w1 is equal to plus minus 1 upon root 2. So from 2 we can also write w2 is also equal to minus w1, hence w2 will also be equal to plus minus 1 upon root 2. Based on the condition whether w1 is positive or negative, we will get w2 as the sign opposite as that of w1. Now if w1 is positive 1 upon root 2, then w2 will be negative 1 upon root 2. And similarly, if w1 is minus 1 upon root 2, then w2 will be positive of 1 upon root 2. And w3 is 0 in both the cases. Hence the two vectors which we were required, which are orthogonal to the given u and v, are 1 upon root 2 comma minus 1 upon root 2 comma 0 and minus 1 upon root 2 comma 1 upon root 2 comma 0. So these are the two vectors which are orthogonal to the given vectors u and v and of unit modulus. Now the second question is, verify Cauchy-Schwartz inequality for the vectors u and v. Now we know that the Cauchy-Schwartz inequality is given by u dot v must be less than or equal to norm of u into norm of v. So first we'll find the dot product of uv and then we'll find the norm of u and norm of v. Now dot product of uv is equal to minus 3 into 2 plus 1 into minus 1 plus 0 into 3, which is equal to minus 6 minus 1, that is minus 7. Now the norm of u will be calculated. Norm of u is given by square root of minus 3 square plus 1 square plus 0 square, which is root 10. Norm of v is given by square root of 2 square plus minus 1 square plus 3 square, which is equal to root of 14. Square root of 14. Now we can write as modulus of u dot v, which is positive 7, must be less than or equal to square root of 10 into square root of 14, and this that is 7 must be less than equal to root 40, which is true, and hence we have proved Cauchy-Schwartz inequality is true.